Welcome back. In our final case study, we're going to be looking at this process called detection engineering. And detection engineering starts from the idea that we have a gap in our detection, that we've realized that there's a gap. It could be from someone calling us and saying, hey, you've got a phishing site being run on your infrastructure. Or it could be from a lessons learned phase from incident response, realizing that somewhere along the way, even though all these things had happened, your team failed to detect it because there was a gap in some way. And so this thing called detection engineering is a process, and it's a process of developing technical means for uncovering malicious activity or even misconfigurations that could lead to malicious activity. And it starts with, as I mentioned, the first phase, realizing you have a gap in your detection. From there, you realize, or you say, hey, I want to fill this gap. I want to bridge this gap, and I need to figure out the data source that I'm going to target to build my detection. And in some cases, after we've identified that, we have to actually configure the data source as well. Now, when we talk about data sources, there's really four broad types. We talk about network data, host data, application data like audit logs from applications, as well as intel like threat intel. And once we've identified the data source that we want to use for our new detection, we may need to configure it. Think about the scenario where you want to build a new network-focused detection, but you actually don't have Security Onion deployed to a particular segment of your network. That would be part of this phase, or part of this process would be actually deploying a Security Onion sensor to that segment and make sure that you have coverage there. So once we've identified and configured our data source, the third phase is simply writing and testing the detection. Now in Security Onion, we have a variety of alerting engines that you can use to build your detections. Things like Suricata and Zeek, Wazoo, Playbook. Playbook uses Sigma and ElastAlert on the back end. So lots of options there, and that's part of this phase, is kind of thinking through what makes sense for the situation you're in and your environment, which alerting engine to use. Now, when you're writing your detection, it's going to be really key to have a target log that you're focused on. So you don't want to just write your detection, hoping that you're going to detect whatever you're trying to detect, right? And that's where testing your detection comes into play. Is we should have that log already in Security Onion so that when we write it and test it, we can actually verify that we generate the alert as expected. Finally, we have deploying to production and tuning. Once you've deployed your detection into production, it's going to be really normal and common that you're going to have to go back and tune it. What's that well-known saying? The idea that your planning's well and good and we should do it, but no battle plan ever survives contact with the enemy, right? You got to move and adjust. You got to be able to be flexible enough to figure things out on the fly. And that's the same concept with tuning. Is once you actually have your detection in production, you're going to have to go back and tune and tweak based on actual operation on the ground, boots on the ground, what it actually looks like. All right. So that is just a real quick introduction to this process of detection engineering. And what we're going to do in this case study is walk through this process. We're going to start out with detection gap. And the detection gap in this scenario is this. Our organization, our fictional organization called Acme Onions, uses Google Workspace, formerly known as G Suite. We use it for a variety of things. We have documentation for IT. We have documents for all of the organization, lots of sensitive data up there. We use Google Cloud. We have our virtual machines and other infrastructure up there. So we really have a lot of sensitive things in Google Workspace. And the concern is that we really don't have any visibility or detection around user and user access, and specifically around administrator roles and users being added to sensitive groups. We want to know when a user gains any kind of administrative access, as well as when they're added to a sensitive group. Let me go ahead and show you what I mean by that. All right, so I am logged into my fictional organization, Acme Onions. For this scenario, we only have 2 users, but you should be thinking that obviously there's a lot more here, right? When I go to manage my users, we have ops@acmeonions.com. This is the main administrator account. And then we have a user, Jonathan Dresden, jdresden@acmeonions.com. So the first concern is administrator roles and privileges. If I come down here, we'll see that I can assign roles. You can see there's all sorts of different roles that I can assign: super admin, groups admin, user management admin, help desk admin. So I'm gonna go ahead and add one there. That's the first gap in our detection, is we want to know when that happens. And then secondly, if I come over to groups and I add Jonathan to a group, there's all sorts of different groups we have in the organization. Some sensitive, some not. Volunteers, organization-wide shared data probably doesn't have a ton of sensitive information associated with it, but definitely HR and finance and IT operations, those would be concerning groups for random people to be added to, right? So if I add that. So the focus here is, if someone maybe accidentally fat fingers some configuration and adds a user to a group or a administrative role that they shouldn't be, or there's something more malicious or nefarious happening. That's what we want to know. And the good news is that if we come down to reporting and audit, we'll see that we do have audit logs associated with this. Check this out. So user J Dresden created under the group IT Ops, and then role assignment, role help desk admin assigned to user J Dresden. So we definitely have logs that are being created when things like this happen, but we have no alerts associated with them. They're not in Security Onion, don't really have any visibility from that perspective in Security Onion. And so that's the goal here, is getting this data down into Security Onion and then building some detections against it. Let me give you a quick overview of how that's going to work. First off, we're going to have to configure our Google Workspace account. That means setting up a service account. We don't want to use like the ops at Acme Onions. We want to use a dedicated service account for that. And we also want to enable API access for that service account. So we have to first configure our Google Workspace account, and then we have to configure Security Onion. We will first configure Elastic FileBeat that is built into Security Onion, and we'll configure FileBeat to use this service account that we created over here. What will happen is every so often FileBeat will log into Google Workspace using the APIs and see if there's any new audit logs. If there are, it'll download them, process them, parse them, and ingest them into Security Onion. Now the good news is that we are able to use FileBeat modules. FileBeat modules are built-in configurations that ship with Elastic that support things like Google Workspace and lots of other data sources. And so all we're going to have to do is simply say, hey, I want to use the FileBeat module for Google Workspace. Here's the relevant configuration information, and bam, that's it. All right, so it is involved to set this up, but it's not complex. All right, it's involved but not complex. Finally, once we have that data in Security Onion, we're going to want to go ahead and create and enable some detection plays in Playbook so that we can generate some alerts when we see these events that we talked about. So let's go ahead and get started by configuring Google Workspace. Now, the good news is that we have some documentation available from Elastic on how to do this. So I have our Elastic Google Workspace module documentation pulled up, and if I scroll down, we'll see that it talks about how to configure it. So in order for Filebeat to ingest data from the Google Reports API, we must do these things. Have an administrator account. Well, we already have one, the ops at acmeonions.com. Set up a service account using the administrator account and some of these other pieces, which we'll do as part of this step. So I'm going to right click and open this in a new tab. And this brings up some documentation from Google. It shows us how to use an automated script to set up this service account, which is pretty cool. So first, in a browser window, open the Cloud Shell Editor. So we'll do that. And it's going to go through and provision some infrastructure for us. And we're going to come back over here. It says, go ahead and run this command. So I'll paste that in there and run that command. So welcome, this script will create and authorize the resources that are necessary to use Google Workspace Migrate. So note here, the script that we're running is specifically used for Google Workspace Migrate, a particular function. We're using this to create the service account and do these tasks. So just keep in mind that it might look a little different, but it's going to accomplish the same purpose. The following steps will be performed on your behalf. It'll create a Google Cloud Platform project. It will enable the APIs, create a service account, will authorize that service account, and create a service account key. In the end, you will be prompted to download the service account key. We'll see that in a minute. And then we can also do this manually, which we definitely don't want to do. That's a lot more complex. So we're going to press enter to continue. It's going to take just a couple minutes to run through this. I'm going to go ahead and authorize this. I'm just telling it that it can go ahead and move forward with my admin authorization. And I'll give this just a second to run through. All right, so it looks like it's done most of what it needs to do. Enable the APIs, created the service account. So before using it, you must authorize the service account to perform actions on behalf of your users. You can do so by clicking right here. So what this is doing is we're saying this service account can hit these APIs. We'll come back to this in just a second because we're going to have to change this. So after clicking authorize, return here and press enter. And it's creating the service account key. I'm going to download this JSON file, which is the service account key. And it's going to give us a warning here. If you've downloaded the file, you may close this page. Please remember that this file is highly sensitive. Any person who gains access to the key file will then have full access to all resources to which the service account has access. You should treat it just like you would a password. So that is the, go to downloads. That's that JSON file. We'll use this in just a minute and look at what that is. All right. Now, if we go back to our documentation, because we finished with the Cloud Shell, it's all done. If we come back to our Elastic documentation, it says that this module will make use of the following scope. This means that the service account that we set up is going to use this scope, the admin reports audit read only. So if we go back to this page, the service account configuration that we currently have, you'll see has lots of other scopes already configured. We want to go ahead and remove this because we want, principle of least privilege. We don't need that service account to have access to all of these scopes. If it's compromised, we want it to have the minimal access that it has. So we'll paste in the one access that it needs, which is a read-only to the audit reports, and we'll reauthorize it. So again, to be clear, we've set up a service account to only have read-only access to the audit reports. So from there, I think we're good to go on the Google Cloud side of things. So we've done this part so far. We set up our service account, we enabled API access, we reduced the access that API, that service account needed. So we're ready to go on this side. So now let's turn our attention to Security Onion, and we'll start off by configuring Elastic FileBeat. To do that, I am going to log into the manager. So I'm logged into the Security Onion manager. And the first thing we need to do is move that JSON file that has the credentials on it to Security Onion so that it can access the API. So we're going to create a file, sudo vi under opt-so-conf filebeat modules Google Creds file.json. And we need to open up that file. Let me make that a little bit easier to see here. All right, so here is that file that we just downloaded. You can see it's a JSON file. It does have our private key in it. So this is extremely sensitive information. Treat this as a password. Now, demo note, this has all been deleted, so no worries on any of this. Once you're seeing this, this has all been deprecated and deleted. So no issue there. So I'm going to copy that, and I'm going to paste that into the new file I'm creating here. And we've created our Google Creds file.json. Next up, we have to configure Elastic FileBeat module. Now, normally we would configure this in a YAML file, a configuration file for the FileBeat modules. But to configure that in Security Onion, we have to do it in the Salt Minion pillar file. If you're not familiar with Salt and Pillar and what any of that means, no worries. We actually have this pretty well documented. Again, I'll put this on the learning management system for you. You have this pretty well documented on where this goes and how to do it if you're still not sure after you watch this demo. So let's go ahead and do that right now. I'm actually going to just make this a little easier to see. So I'm going to open up the Minion pillar file for my manager. And there's lots of information about the system and the configuration here. I'm going to go to the very end and I'm going to paste in the configuration for the FileBeat module. Now, I already have this pre-configured for us. And let me explain it a little bit. So it's referencing FileBeat, third-party FileBeat modules, the name of the module, which is Google Workspace, and then you have some Google Workspace configuration, SAML, user accounts, login, admin, things like that. We specify the file, the credential file. Now you may be saying that path does not match the path that we created under. Remember that FileBeat runs in a Docker container, so it's actually referencing the Docker container file. This is also documented under our documentation if you're not sure of where to put your files, so no worries on that. The delegated account, this is our admin account, and then the interval. So by default, the Google Workspace module reaches out, I think, every hour, if I remember correctly. I changed it to every 60 seconds just to make it easier for this demo. And that may be something you need to tweak in production. So I'm going to copy that and I'm going to paste that into our pillar. Everything looks good. Remember that Salt and these files are all YAML. So these are not tabs, these are spaces. If you're editing YAML and you're using tabs, you're going to have problems. Make sure you use spaces. So I'll go ahead and save that. And what do you think we have to do next? If we have changed the configuration of FileBeat, in order for FileBeat to pick up the new configuration, we probably have to restart FileBeat. That's right. So we'll say so-filebeat-restart, and we'll go ahead and restart FileBeat. It looks like it restarted without any issues. I don't see any failures right here. We can also check by tailing the log file. So that's opt so log filebeat and filebeat.log. Now you may be saying, Josh, how in the world would I know where this is? Let me show you real quick. Let me log back into Security Onion. If we go under here and go to the cheat sheet, this pulls up a handy dandy little cheat sheet for us. Gives us a lot of great information about where to find things, how to restart services. If we scroll all the way down, important configuration files. Then finally, diagnostic logs. So FileBeat, opt-so log FileBeat. All right, so this cheat sheet is really, really useful as you are learning Security Onion, or even if you've used Security Onion for a while. It's not always easy to remember where everything is. All right, so our log, everything looks fine. These are errors from a previous thing that I was looking at. So it's looking good so far. No errors from the current run, the current restart. And so we can actually verify that we have a new index with our workspace logs in them by running this command, so-elasticsearch-query. So it's going to query Elasticsearch, and it's going to cat the indices, and we're going to grep for Google Workspace. So let's go ahead and do that. And we see that we actually have two indexes with a couple logs in them. So this is looking great. So if that's the case, let's go flip over to Security Onion, and we should see those logs in Hunt. Side note, we're getting this exclamation point because we just restarted FileBeat. So Security Onion is saying, hey, there may be something wrong with the grid. This will turn off, this little indicator will turn off in just a minute once it realizes that FileBeat is back up and running. So if we come over here to Hunt, we are looking at the data grouped by event.module and event.dataset, and we see we have lots of different types of data of OSEC, Kibana, Zeek, and we do have Google Workspace logs. We have two different types so far, login. So this would be information about users logging in. And we have admin logs. If we filter for those, get an idea of what some of these look like. So we have an event.action. That would probably be a good group by. And there we go. So we have assign roles, authorize API client access, add group members. This is the kind of data that we're looking for. Remember, assign roles. This would be assigning like admin roles, right? So if we scroll down, we should see that the admin role name is help desk admin role. The user email is J Dresden. That is looking correct. The source username, so who did this? It's the ops@acmeonions.com. All right, so we've got the data in here. This is looking good. So what is our final thing we need to do here? We've set up Google Workspace. We've configured Elastic FileBeat to bring that data in. Now we need to create and enable our detections. So to do that, let's look at our, right here. Let's go back to our directory, our users, Jonathan Dresden, and let's add this user to another group. No, let's do the admin roles and privileges first. So when we look at what default roles are here, it's really the admin ones that we're concerned about, right? And so we probably want to write a detection that says, hey, anytime we have a user added to a or given an admin role that contains the word admin, we have groups admin, we have user management admin, services admin, super admin. Anytime we see a user with an added role that contains the word admin, go ahead and generate an alert. So super admin, right? Something like that. We want to get an alert generated for that. So if we come back to our Security Onion Hunt interface and we look at what we have right here, we see that the name of the role is in this field name, role.name. So we probably need to just simply say, anytime I see this event type with a role name that contains the word admin, go ahead and generate an alert. So let's do that right now. Let's go to Playbook. If you're not familiar with Playbook, Playbook is an application inside Security Onion that contains detection plays. Once you enable these plays, you change their status from draft to active, they will go ahead and generate alerts based on the configuration that they contain. Now, plays are created from Sigma rules. Sigma rules look like this. Let me pull one up for you. So here's one that I've created. A Sigma rule looks like this. It's written in YAML. We have our field and our values, and it's generic from the perspective of I'm not specifying in my rule any specific query language. Let's say I'm using Splunk or Elasticsearch. You can see that's not actually, the query language is not in here. What's going to happen is I'm going to write my rule generically. I'm going to run it through the Sigma converter. I'm going to say, hey, convert this rule into an Elasticsearch query or a Splunk query, and it will go ahead and do that for me. So what we have for our first rule is our title, Google Workspace, user granted admin role. The status is experimental. The description is detects when an admin role is added to a user. The author is Security Onion Solutions. The log source we don't really need to worry about right now. The detection clause, this is something that we want to take a minute and look at. We're simply saying in this detection clause, if the log has a field name event.dataset with this value, a field name called event.action with a sign role, and a field name of Google Workspace admin role.name, and it contains the value admin, go ahead and generate an alert. All right, that's what this detection clause specifies. And then finally, we just simply say it's a high level. There is informational, informational, low, medium, high, and critical. We're saying this is a high severity. So we're going to copy this, and we're going to go ahead and drop this into Playbook. Now again, Sigma, this is our Sigma rule. We're going to convert this into an Elasticsearch query. That's what's happening in the background is we have the Sigma converter. It's taking this rule, it's taking the configuration that we have specified in the back end, and it's spitting out this Elasticsearch query. I can copy this, I can test it, make sure I'm going to get the hits I would expect by pasting it into Hunt. And it says 6 found. And this is from just a minute ago. Remember, I added Jay Dresden to the admin role, and we did get an alert for that, or excuse me, we did get a hit for that. So this appears to be working just fine. So I'm going to create the play from the Sigma rule. It's going to take just a second, and it's going to create the detection play in Playbook for this rule. You can see that it pulled out like the title, the author, the objective. We still have the sigma in here. It actually uses ElastAlert in the backend if you're familiar with ElastAlert. Now I'm going to make this play active. Change the status from draft to active and click on submit. And this is going to put this play into production. If I look at all of the plays that I have lots of draft plays. I have one active play, the one that I just created. Now, anytime we have a user granted an admin role, I should actually see an alert generated and it'll pop up in alerts. So I'll go ahead and do it one more time and we'll wait for it to generate an alert. While we're waiting though, we'll go ahead and do our other detection, and that's the groups. So we want to add Jonathan to a sensitive group. If we look at the groups, not all of these groups, as I mentioned before, are sensitive, but in particular like HR, finance, IT operations, these are sensitive groups. So let's add Jonathan to the finance group. And let me pull up and show you the detection play, or excuse me, the sigma rule that I've already created for this. So Google Workspace, new user added to sensitive group. This detects when a new user is added to a sensitive group. And the detection clause right here simply says if the log has Google Workspace admin value and add group member, and the group name is HR or finance, then go ahead and generate the alert. So we're not saying all groups, we're just simply saying sensitive groups. If it's HR or finance, go ahead and generate an alert. So we will copy that and we'll create a new detection with that. So we'll paste that in here. I'm going to convert this. And I'll copy what was converted, bring it over to Hunt. Paste that into Hunt, and I'm testing my rule here. I'm wanting to make sure that I actually am getting a log found. And I do have one log found. I think this is actually from yesterday. When I was testing this, it was added to HR. So this is looking good. So I'm going to go ahead and create my new detection play from Sigma. And I need to enable this before it's going to generate any alerts. Now, if you are testing this for yourself and you're creating plays, keep in mind that ElastAlert is currently set by default to run every 3 minutes. So even if you have new data coming in and you make a play active, it could be 3 or 4 minutes before you actually see an alert generated here under the alerts interface. However, we've already got one generated for our admin role. So Google Workspace user granted admin role. We can go ahead and drill down into this, but it's looking pretty good so far, right? And if we come back and click on refresh, yeah, it hasn't come in yet. We will get the other alert generated here in just a second. I'll pause the video and come back in just a second to make sure that it is working. All right, there we go. We were able to generate alerts for both when a user was granted an admin role and when a new user is added to a sensitive group. So to summarize, we ran through the detection engineering process for the detection gap of not really having any visibility or understanding of when Google Workspace users are added to sensitive groups or added to admin roles. And then so we identified and configured our data source. That was Google Workspace and the audit logs, configured that and brought them into Security Onion. We wrote and test our detection using a Sigma rule in Playbook. We then deployed that play into production. And as for tuning, there's certainly opportunities for tuning in the near future as new sensitive groups are added. You may find that the current iteration is just too chatty. You may need to tweak it a bit to make it just not generate as many results. Again, it's going to depend on your organization. So that's about it for this case study. I know we went through a lot, but I wanted to give you just a real quick taste of how to run through this detection engineering process and what that looks like specifically using Security Onion. Thanks again, and we'll see you soon.